All right, let's talk about surface area. So, as its name suggests, surface area is the area of an entire surface. So we're talking about actual 3D figures, right? And so surface area is just take the area of all the different sides and add them up together. That's all it is. So if I took a cube, for example, remember a cube, all its side length, its width, its height, they're all the same. So that's why I went ahead and called everything just S instead of L, W, and H, because they're all equal to each other. And then what I'm doing is I'm imagining this cube to be a box, like a cardboard box, and I've opened it up and folded it out and laid it perfectly flat on the floor. And this is what we'd have. This is a 2D net of our 3D figure. So you can imagine if I took that and kind of folded it up, right, like this, and I took this one and I folded it up like that, and then this one I folded it up, right, so this would be my base, and I would fold that guy up, and then this over here, this last square, that would be the top of the box. So what we've done is we've just flattened it out, folded everything out, and we have our net here. So we said at the beginning, surface area is just the area of the entire surface. We have our entire surface here flattened out. So if we find the area of each of these squares and then add them up, that's going to be our surface area. So remember, all of the dimensions, the length, the width, the height in a cube, they're all equal to each other. So this area would be S times S. This area would be S times S. This area would be S times S. This one is S times S. So is that one, and so is that one. So I got 1, 2, 3, 4, 5, 6 S times S's. So that's why the surface area for a cube is S times S times 6, because there's 6 of them. So if you simplify that down, you get the surface area of a cube is equal to 6 times S squared, where S is equal to the side length of the cube. So if I took a rectangular prism, right, where the dimensions are not all equal, unlike the cube, we'll have a different looking net and a different looking formula, but just try to visualize this in your head, what's going on here. So over here, this rectangle here, that's our base. That's the bottom of this rectangular cardboard box you can imagine. These pieces over here are the sides of that rectangular prism. So we folded them out like that. And then we have this front side and the back side there. Those are going to be these two rectangles, and then the top of the box is over here. So you know how to find area of a rectangle. So we're finding areas of 1, 2, 3, 4, 5, 6 different rectangles. And it's not really 6 different rectangles, there's just 3 different ones, and each of them come in pairs. So I'll show you what I mean. This here, that's gonna be length times height, right? I have the same exact rectangle over here. So I'm gonna have 2 length times heights, two rectangles that have an area of length times height. So that's what I'm doing times 2. Width times height, that's going to be this guy over here and this guy over here. So W times H will give me 1, but I want 2 of them because there are 2 of them. And then same thing with the length times the width. That's going to be here, the bottom of the box, and then the top of the box. So I've got 2 length times width rectangles. So this formula here, this one works just fine, but if you're familiar with factoring and simplifying equations down a little bit, you could also use this guy right here. So what all you would do is you would find the area of each of your 3 unique rectangles, add those together, and then multiply the entire number there that you got when you added everything by 2. So again, surface area, the area of the entire surface. You want to imagine you're unfolding the figure that you're given into its 2D components. Find the areas of each of those, add it all up together. So I don't want to go too much into this right now because you'll go over it in geometry later on. I'll probably do a video of that whenever I get to that topic. But just wanted to illustrate what nets are and the concept of surface area. And then last thing here, just here's 3 other 3D shapes and what their nets look like. So I'll leave it up to you to try to figure out what the formulas might be. And the easiest one that probably you'll have the easiest time with figuring out is a cylinder here, because you know what the area for circles are and you know what the area for rectangles are. So I think you could figure out the formula for surface area of a cylinder.